Let us understand the immutable nature of data types in Python. So we say integer is immutable, string is immutable, but list is mutable. So what is the difference between immutable and mutable data types? If you talk about immutable data type like an integer, I say a is equal to 100. I store 100 into a. So somewhere in the memory, you have this value 100 stored. And your a is pointing to that. You have to visualize it in that way. And this is the location where we have 100. Let's say the address of that is something like 550, some imaginary address. Now A is literally storing that address, 550. So this is how you perceive that. So A is 100. So A is pointing to a block or an object where you have 100. Fine. So what happens when you say A is equal to 200? Now, many think this 200 is going to be placed here. No way. If that is the case, it's not called immutable. It's called mutable. Instead, what happens is you get 200 stored somewhere else, like this. And your A is no longer pointing to this old object. Instead, it is now pointing to the new object. And it might be in a different address, obviously. So let us say it is at address 700. So you're going to see that 700 placed here. So it is no longer 550, it is now 700. So every time you change the value of this immutable object, immutable type like integer or float or string, all of them are immutable. So this A is now pointing to a new location where you have the new object, new value. The old one is no longer accessible. Of course, Python takes care of this. It is removed from memory. But your A is pointing to the new object. So you're not going to change this. You're going to point it to a new object where 200 is placed. Now, let's see how this is really working. Let's prove this point. So let's go to our REPL. And here, let's say A is 100. And let's see the address of A. Because address of A means to what location A is pointing. So A is now pointing to location with this address. Let's consider only last 3 digits for simplicity, 760. And then you change the value of A. When you change the value of A, we are now changing the address to which A is pointing. Because according to what we discussed here, A is now supposed to refer to a new location where the new value is placed. So let's go and then see whether that is right. ID of A, and there you are. It's no longer pointing to 760, it is pointing to 960. This is how immutable objects are working. So A is integer, means immutable. It cannot be modified. What it really means, it's not that you can't change the value of A. You can, but it's not that you're changing the same location. You're instead putting the value in a different location and your A points to that new location. This is not something many understand, but this is the way it works internally. So when you assign 100 to A, it is pointing to one location where the value is stored. But when you change the value, it points to a new location because that's where 200 is stored. And your A is the same name, but it is having a different value. And then if you say B is equal to 100 and say ID of B, and do you see it is now pointing to the old address? What's happening then? This 100 is a constant. So it knows that the 100 is already there in the memory and your B is made to point to that object. And it's the same address you have seen before. So Python is intelligently using the same address because the object is still there. It is not removed from memory. So this is the way it is going to store those numbers in memory. They're all objects basically, because if you see what is the type of A, it says it's an integer class. And don't worry if you don't know much about classes, but the point here is everything is internally like an object. So an integer is an object, the float, string, tuple, list, everything is an object. So this is initially 100, that is the address. And then you set it to 200, this is the new address. But this 100 is still there in the memory. So when you say you want B to be set to 100, it knows it's already there and it is going to assign this object to B. That means B points to this location. That location means the location where 100 is present. So coming back to this, we can now say after that when you give B is equal to 100, it says, okay, 100 is already there. So your B should be pointing to that. This is your B and it says, okay, 550 and this is now pointing to. So this B is now pointing to this location because we already have 100 there. But A is pointing to the new location and this is no longer the case. So we are not pointing to that anymore. This is the way it is internally working. So I want you to understand the immutable nature because this is important in good number of contexts. So when you change the value of a variable, you're not changing the value in that location of memory. You're creating a new object. That's where the value is placed. And you can see that in your REPL, you can clearly see the way the addresses are changing. So for A, this is the address. But as you change the value of A, the address changed. So it's easy to get to REPL and understand how things are working under the hood. So this is about the immutable nature of your objects. This is true for strings, this is true for floats and all immutable types. Okay, but if it is a mutable type like a list, it's a different ball game. You're not going to change the address of list. For example, L is 1, 2. It's a list and see the address of that. And you want to append something to list. And then if you see the address of this list, it remains the same. You are modifying the list because list is mutable. Your list is mutable. So initially this is the address. Even after you append something, the address remains the same. So there's a lot of difference between the way it handles mutable and immutable types.